Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how does the value of c affect our quadratic function. So here we're talking about adding a plus c on the end. Now that c is going to be a constant value. So we're talking about what happens if I add something like x squared plus 7 or 3x squared minus 4. How does this plus 7 and this minus 4 affect our graph? Now in the previous video, we talked about how a affects our x squared function. And remember, a has kind of two components. If it's positive, it's going to open up like a smiley face. If it's negative, it's going to open down like a frowny face. Also, depending on our a value, so if our a value here is something greater than 1, then remember it's going to have a vertical stretch or it's going to get thinner. And if a is somewhere between 0 and 1, then it's going to have a vertical shrink and it's going to get wider. And so remember that these work in combination. So if I had a negative 1/3, what that means is it's going to be open, down, and it's going to be wider. If I had a positive, or if I had a negative 6, then it's going to be open, down, but it's going to be thinner than my original x squared function. And that's kind of how that a works there. So now we're going to talk about what happens with c. Just like when we were discussing our absolute value functions, this plus c tells us how the function is going to shift up or down. So if c is positive, it shifts it up. If it's negative, it shifts it down, and it just shifts it up and down that many units. So when it's a positive number, it's going to shift it up c units. If it's a negative number, it's going to shift it down that c units. Okay, so this blue line here is our f of x equals x squared. This green one would be when f of x equals x squared plus a c, and this red one is when our c is negative, so f of x equals x squared minus some constant. That's what those look like. So let's take a look and graph these all together. I want to sketch these graphs and see what we notice. So in this first case, I'm going to be graphing f of x equals x squared and g of x equals x squared minus plus 2. So I'm just going to graph these and plug these numbers in. So I'm going to start at x equals 0. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. That goes off my graph. Negative 1 squared is 1. Negative 2 squared is 4. And negative 3 squared is 9. So this is what that f of x function looks like that. Now when we do this other function, remember plus 2 means I'm going to take my x squared function and those values. So remember, we had our 0 squared equals 0, 1 squared equals 1, 2 squared equals 4, 3 squared equals 9. And then remember, this is going to be symmetric. Oh, this is going to be symmetric about our x-axis, or our axis of symmetry is when x equals 0. And that's going to be the case with all of these. And so we know that after that, when we go to the other side of 0, so negative 1, negative 2, negative 3, it's going to mimic it. It's going to look the same. So in our new one, we are adding 2 to all these values. So instead of being at 0, I'm going to start here at 2. Instead of being at 1, I'm going to go up to 3. Instead of being at 4, we're going to go up to 6 when we have x equals 2. And instead of being at 9, I'm going to go up to 11. And remember, we're symmetric about the y-axis here, or x equals 0. And so it's going to look exactly the same over here. And here's what our graph looks like. So notice how it looks just like that blue graph, but I just took it and moved it up. That's all that this function does, is it takes whatever we had before and it moves it. So let's take a look at this next one over here. I've got f of x equals 2x squared and g of x equals 2x squared minus 2. What I want you guys to do is graph this one on your own. So remember, figure out what this f of x is first, graph that on there, and then follow it up by graphing this g of x. Now notice the big difference between our f of x and our g of x is our g of x is minus 2. So remember, it's just going to take our original f of x function of 2x squared and just shift it straight down 2. So I want you to pause the video, do that on your own. When you've finished, unpause the video and compare your graph to my graph. Okay, hopefully you've had a chance to graph this function here. As we've graphed this function, you can see that all it did is it took our blue function, or that f of x, and it moved it down exactly to on our y-axis. And that's what's happening here. So what I want to do is we are going to just practice this. So we're going to do this same thing. We're going to graph our f of x equals x squared and compare it to our g of x here. Now, on that last image, we were being pretty precise about how we graphed it. On this one, I just want to see a rough sketch. So here we've got this line. I'm going to graph. This is kind of what x squared looks like, right? Roughly. X squared minus 2 just means instead of starting here at 0, 0, it's going to look the exact same, but it's minus 2. Notice it's just a rough graph, but it shifts down. Now I want you to do these next two on your own. So our f of x, I'm going to graph it in blue. That equals x squared, and I want you to compare it to our other two functions. Our g of x equals x minus 5, and our h of x equals x squared plus 3. Now I'm going to graph all three of these on the same axis. Feel free to do it on two separate axes or on the same one. What I want you to do is pause the video, graph them, and then come back after you've graphed them. Okay, hopefully you had a second to graph those. Now I graphed both of these. Blue here is my original f of x function, where it equals x squared. Now my green one here is our g of x function, and the purple one up here is our h of x function. So notice the function looks exactly the same. The only difference is the g of x is moved down 5 and the h of x is moved up 3. So that is how that value affects it. And we can just move it around that way. Now this is how that c affects it. What I want to do is I want to look at some examples of how we might graph it when it's got both an a and a c that affects it. So we want to graph this g of x compared to this f of x. So I'm going to graph my f of x in blue, my g of x in green here. So here's my graph for my f of x. And I'm going to start, remember this starts at 0. It's going to look kind of like this. It's not going to look perfect. I'm doing a rough sketch. Now, what does this positive 4 tell us? Well, it tells me it's going to open up like a smiley face, and it's going to have a vertical stretch. So it's going to get thinner by a factor of 4. This plus 1 tells me that I'm going to move it up 1. So my vertex is now going to start here at 1. And I know that this is going to be thinner than it was before. So this 4x plus 1 is actually going to look something like this. Now that's not precise. I don't have measurements drawn on my axes, but as a rough sketch of a graph, this is kind of what we're looking at. Something that has a vertical stretch, so it's going to get thinner. So that vertical stretch, it's going to be open up, and it's going to be shifted up 1. Now, in this next example, what I want to look at is instead of comparing something to f of x, where f of x equals x squared, what we want to do is compare it to this other function and then say what happens. So right here, we want f of x to equal negative 0.5x squared plus 2 and g of x equal f of x minus 7. So it's that same function minus 7. So when it asks us to describe the transformation, what they want us to do is describe what happened to it. Where did it go? So our transformation, this minus 7 is our transformation. And it means that it moved down 7 units. Right? So then when we graph f and g in the same coordinate plane, what that means is I'm going to graph a rough sketch. So this f of x here, I'm going to start with the negative 0.5 tells me that it's going to be open down, and it's going to be a little bit wider than my x squared. And this plus 2 tells me that my vertex is going to be at 0, 2. So here's my vertex for that green one. It's going to come down, but it's going to be a little bit wider than what I would have expected. Okay, so that is what my f of x looks like. My g of x is going to be that same function, but I'm going to now move it up 7. So it's going to look exactly the same as I can draw it, but it's going to be up 7. That's what that looks like. So what they want us to do is then in part B here, we're going to describe the equation that represents g in terms of x. What that means is instead of writing g of x equals the function f of x minus 7, I don't want to write f of x, but I want to write what the function f of x is. So in this case, I'm going to write g of x equals, instead of f of x is negative 0.5 x squared plus 2, and then our minus 7. Oh my goodness, I graphed that wrong. What should have happened is our blue line here should not have gone up 7. It should have gone down 7 units. And so instead of being there, we have a graph that looks the same down here. Now that looks more correct. So then as we shift it down, we have g of x equals negative 0.5 x squared minus 5. And we can see that that shifted down down 7 units. Our new vertex is at 0, negative 5. I apologize for making that mistake. I make mistakes all the time, just like you do. Again, we were moving down 7 units, so I needed to draw that blue function down 7 units, not up. So we can do this over and over again. But whenever we see a problem that says describe the transformation, what they're talking about is based on our original function. So if I had an x squared, and now all of a sudden I have an x squared plus 3, the transformation there is that it went up 3. If it's an x squared minus 6, the transformation is it went down 6. That's what's happening with those. So in summary, this is what that C value does. Our C value affects where it is by moving it up and down. It gives us this vertical translation, either up or down, depending on if C is positive or negative. If it's a positive number, it's going to go up that many. If it's a negative number, it's going to go down that many. And that's how C affects our quadratic function.